Once we realize that how R works, then we will move on to Spark R, and we will also talk about GraphX. But before jumping to GraphX, we'll try to do similar thing using R. All right? Am I audible to everyone? Good, good. All right. So here we are. All right. So this is a very interesting topic. It will touch upon the basics of analytics, and it will touch upon the strategies used these in the analytics. Okay. So we will go from statistics, we will go through the statistics and statistical inferences. So be ready to do a little bit maths. Okay. All right. So the general process, general approach to any business analytics or any kind of analytics is you first understand the problem, business problem you're trying to solve, then understand the techniques available, then understand what kind of underlying tools available, try out tools, try to fit the tools into your problems, and then solve your problem. In case you get stuck at any point, you move on to go back to understanding business problem and trying other techniques and tools. Okay, so this is like a iterative process. Probably it's very common sense, but we forget it a lot of times. So the whole process starts with understanding a problem you try to solve. Okay, and the kind of problems we are going to solve is related to data. Given a data, you, let's say given a particular data, you have to find a kind of pattern, find how is the data spread, or whether a particular hypothesis is true or wrong. Okay, so we will go into examples and you will understand what is it that we are talking about. So we have discussed a bit about various tools, and let's discuss a few techniques as well. All right. So what is business analytics? Business analytics is study of business data using statistical techniques. Okay. Programming for creating decision support and insight for achieving business goals. So these are general ideas. Overall, the idea is look into the data, solve your business problem, look into the data, come up with interesting strategies. So that's what is the analytics about. Okay. And a very common question is that people ask me quite often, what does it mean by data science? So data science and data analytics overlap a lot. Okay. So data science also includes the interesting ways of presenting the data and the the little bit so data science is little basically data science as per this diagram is an intersection of ability hacking skills, maths and statistics knowledge, and substantive expertise as in the subject matter. So it, having an expertise in the subject as in a particular vertical combined with the hacking skills as in ability to quickly solve the problems and combined with the maths and statistics knowledge is something called data science. If you have got the substantive expertise in the subject matter and you have got hacking skills, it could be a dangerous thing. Okay, because you might utilize your hacking skills and your subject matter expertise to do wrong things. Okay, but if you have the hacking skills and the maths and statistics knowledge, but you don't have the subject matter, then you have the general knowledge about how to do the machine learning. You can do the machine learning kind of things. So this is a general definition of data science. So data analytics and data science is almost overlapping, just that we will not get into maths too much, we will just get into statistics. Okay, all right. So, and also at the same time, we will first get to know a bit about R, just a little bit about R, so that these simple functions we can quickly do and analyze our data. Okay, so every time I talk about an idea, you should think about how can I get it done through R. Okay, so uh, so basically, R is a language which was it's pretty old. It's not new. It was designed in 1970s. It has got a traction lately because of so much focus on the data lately. Recently, there has been a lot of focus on data analysis, and since MATLAB was not open source and there were other tools which were not open source. That's why people went for R, because R is very powerful. R has got the biggest library out of all the tools, and uh, and R is open source. All right, so it's based on another language called S, and S was invented along the side with C at Bell Labs. Okay, provides you a great studio called R Studio, which you can simply download and get started. Okay, you can just go to the website and start downloading R Studio. And although we can install R on our CloudX Lab, but the problem is it won't give you a nice display, nice UI. All right, so we have got visualization and graphs in R. It provides you a way to quickly plot data and look at the data. It's open source. There's a great, vibrant developer community called CRAN. It's extensible. You can write your functions in C, C++, Java, Python, and .NET. And R provides you a great tools for modeling, analysis, clustering, classification, and general statistics. So R provides you all kinds of big libraries to do these kind of work. R is also object oriented. Okay, so there are different versions of R, and let me add one more, and we call it Spark R. Spark R. Okay, we will also talk about what does it mean by R. So Mehdi's question is, what is the difference between programming in R and Spark R? So basically, the way I demonstrated that we could write our code using Java or Python, in the same way you could write your code in R. Also, the difference between R and Spark R is, from the usage perspective, R cannot handle data which does not fit into memory. If your machine has got 32 GB RAM, R will not be able to handle data up to 32 GB. Okay? If data grows beyond 32 GB, there's no way R can handle it. But Spark R can. Spark R can, by the way of loading the data into RDD, and Spark R makes look like the data in the form as if the R is expecting. So that is the difference. That is the difference. So just like SQL makes the data look like in the form of a table, right? In the same way, R, the basic premise of R is something called a data frame. So in case of Spark R, data frame is data frame is located on the uh, so data frame in case of Spark R is nothing but an RDD. Okay, good. All right. So there are many different kind of R's available. There is something called Revolution Analytics R for Enterprise. There is distributed R from HP, and there is streaming job in R, as in if you want to process some data using batch processing, what you can do is you can write your R code which considers individual sections of the data as input and does something and saves in the output. So the way we showed we ran our shell program as the map reduce, in the same fashion you could use R to process the input data and generate the output. That is streaming job with R. Spark R is Spark R is the Spark R is nothing but a layer on top of Spark. And the way Spark let you manipulate data in Java, Python, in the same way it lets you manipulate data through R. And that's called Spark R. Okay. So you can directly download the R either from R project or preferably from R Studio. Okay, let's take a break of 5 minutes. In the meantime, try to install R Studio. Okay, it should be pretty straightforward. All right. Yes, let's take a break and back by Hi, I'm back. So should we start now? Mendi and Sahab. All right. So you can download the R Studio and get started. All right. So this is the starting point at R Studio. Okay. So all right. It didn't look good. Okay. So I'm just trying to reset. Just a second. Okay. All right. So do you see here what is the after you start your session, this is something you will see. The important part here is this locale, sorry, this console. This is where you will be typing your command. Okay, just like you had Python command prompt, or just like you had PySpark command prompt, in the same way you have a command prompt here. Here you write an expression, get it executed, and then you see the results. Okay. And all right, so that was the way you can start. You can download RStudio and then start. All right. So it's a great way to start R using RStudio. Okay. And in case you are looking for a more developer like user interface, you might go for Deducer, but that's just another UI, but R remains same. Okay. So RStudio is an IDE that was built just for R. It brings all the workflow together. It provides you authoring and debugging. All right. So R, I think it is installed, but not sure. Okay. R, I'm not sure if it is installed or not. All right. So yes, that's little difficult thing to do right now. This is little difficult thing to do for you. There is a way you can run R on the server and get the UI on your local machine. Okay. All right. So let's get started with the hello world in R. So you can define a variable. You can define a variable like this in R. Let's try to define a variable. When I say x equals to hello world, so you can see x is hello world. Okay. All right. I think this is more visible. So when I say x equals to 10, it's a number. Okay, so this way you can define and you can say things like this. All right, the older notation, or you can say alternative notation of assignment, is this. Okay, this is equal to, this is this and this, the previous statement. These two statements you see here, they are doing the exact same thing, so don't get confused if you see something like this. Okay, it's the same thing. In case you want to exit, you can at any point of time you could say q, and it'll ask you to save the workspace or not. Okay, now if you want to see the help on any of the functions, you could say help, and then it should show you the help. Okay, and all right, also you can use it like a small calculator. Okay, just like you were using Python. And in case you want to look for the example use cases of a function, you could say things like example and print. So it's showing you in detail. How can I? Yeah. So you can see here, it's showing you in detail, as in what are the various. When I said example print, it is showing you the detailed uh, use cases of print. So you can see that for I in 1 to 3, you can print things like this. Okay, and so you can see there are a lot of things you could do with print itself. All right, so that's just very basic use case of R. So this could serve as a good example for you to start. Okay, so why isn't it showing the help? I think I need to say help dot start. I think my R Studio is need to be reinstalled or something. Okay, and in this R Studio you can exit and everything will be saved. All right. Now this is just basic, where we defined a variable, two kinds of variable. One was string and other was a number. And also we demonstrated how we did small maths. So we could do things like, so we can do a lot of maths quickly. And okay, so you can see that it takes care of the decimal numbers very well. All right, now there is another aspect. It's called vector. Just like you had heard about arrays earlier, we have vector here. Vector is basically a representation of multiple values together. Okay, so when I say x equals to 1 comma 2 comma 3, okay, x equals to 1 C1 comma 2 comma 3 is basically I'm defining a vector. The cool thing about vector is you could do things like this, and when you say x into 2, 2 got multiplied on every value of x and we got a new vector. Although x is still this, but if I say y is equal to this. Now you can see y is this, x is this. If I say plot x comma y, it should show me, okay, why isn't it plotting things? I think I have uninstalled Quartz. Okay, let me try now. It did not work. Or maybe I think what I should do is I should just let it download and install again. Because access this, why is this? We could have just quickly installed it. So I'm going for R desktop, going for free AGPL version. Okay. I'm going for Mac OS version because I have Mac. And all right. Now at the same time, you can see here. All right. Now, what I was trying to demonstrate to you is when you have a vector like xc1 comma 10. Okay, so you can see that it has automatically generated the sequence. Okay, and you can see if I want to add one more variable into this, I can add easily. You can see that I have added first 1 to 10, you can see, and then 4 to 5. Okay, so if I want to say y is equals to x multiplied by x, so what do we have? We have the square of x. Okay, we have, if you want to say y is equals to x square plus 3, so you have this. All right, let me just try to exit and reinstall. Probably it will work then. All right. R Studio. All right, so we have, let's say, and we are saying plot x comma y. Did it work? I doubt. Mhm. My plots is not working. Otherwise, it could have shown. By now, it could have shown. Probably I need to install some more things. So Quartz. All right, I need to have a look at it. Why exactly my graphs are not working, but that's okay. We can do it later also. So the idea that I was trying to say, that you can define an array of values in the form of something called vector. You could either say, so this is basically an equal sign. Here we are saying X is an area of containing this, or you could also look at X like a tuple in Python. So you got four values in this vector. Okay. You could also compose another vector by concatenating x, 0, and then again x. You can see 10, 10.4, 5.6, 3.1, and again up, then 0, and then again repeated. Okay, so that's a very quick way of doing your mathematical operation. Okay, that's a very quick way of doing your mathematical operation. If you want to just multiply all the values by 2, you could do 2 into 1. See that? Okay. Now, what if our x is this? Okay. So I'll try to show you this. So we have, let's say, x is equals to vector c up to up to up to say 20. Okay, so we have x from here to here. Now let's say we want to add again and again another vector. So I want to say x plus 3 comma 5 c 3 comma 5 comma 7. Okay, so longer object length is not a okay. All right. So what has happened? So we had x this, and we are trying to add another vector to x. So what happens is it will try to add 3 and 5 to 1 comma 2, and then again and again it will keep on applying this small vector on a bigger one. You can see 9 plus 3 is 12, 10 plus 5 is 15, 11 plus 3 is 14, and so on. So when you have two vectors adding, if the second one will be taken and apply on the bigger vector again and again till the end. Okay, just that the second smaller vector should cover all of the element. It should not happen that that was the reason when we were saying 3, this vector was not fitting in, like 3 here, then again 3, and again 3, and again 3, and again 3, and then again 3, and here one element was less. So two vector additions, even though vectors are not of equal size, the smaller one should be a factor of the bigger one. Okay, so is the idea of a vector clear to everyone? Okay, so try doing these operation by yourself. You can generate a vector by either using range or concatenating numbers, okay, or by multiplying or addition of another vector. Further, on top of vectors, you could do many magical things. Okay, so let's say we have x, we could say something like this. Okay, you could say summary of x. You can see what did it do? It gave us the minimum, the maximum, the mean, and something like first quadrant and third quartlet. We will talk about this first and third thing later. But median, mean, max, and min, it gave us a quick statistics about our vector. Okay? It gave us quick statistics about our vector. We will talk about these two numbers a bit later, but I hope you understand the mean and median's difference and max and min's difference. All right, so you can do lots and lots of functions on top of vector. Okay, so vectors are very important. They are nothing but sequential values, okay, on which you can do various kinds of operations, such as you want to even, let's say there's something called x, and then when we say mean of x, it gives us the average of x. And if you want to compute the standard deviation, we can either use standard deviation of x, or what we could do is s minus mean of s, this is here, and then we say we square it, we square these values, okay, we square these values, okay. I think this is not right, we have to use mod. Okay, we have got this, and then we can divide it by length of x minus 1. So you can see it has given us this number, which we can further sum. Okay, and then we can do, of course, square root. So you can see that we have computed standard deviation by ourselves. Okay, so if you remember what is the standard deviation? Standard deviation of an array is find out the mean, subtract the mean or average. What is mean? Mean is sum all the values and find out the middle value. Okay, sum all the values divided by total number of values, that is your mean. Now what we want to compute is how much your values are varying away from the average. If the values are varying a lot from the mean, your standard deviation will be bigger. Okay, we will go into the meaning of standard deviation again, so no worries. All right, so we were able to compute the average using these kind of functions, sorry, standard deviation, by either this or by using SD as a function provided by R to us, or sometimes you want to just order these values. Okay, you want to sort these values, which is already sort for us. We could reverse sort it. Okay, not like this. Decreasing equals to true. So we could sort the values by increasing or decreasing using this kind of a syntax. Okay, so that's about sorting, and you can generate a sequence, a vector from the sequence. So we could say sequence 1 2, and we could say step equals this. Okay, by I think the, okay, so you can see that we started with 1, we started adding by 10, and it went up to 200. Okay, good. Now that was a way to generate a vector sequentially, and then you could also say things like repeat a particular vector again and again that many times using a function called REP. You could see that here. So S5 basically contains 1 2 1 2 5 times. Okay, sounds good to you? Similarly, you could also say things like each of the values of this vector should be how many times. Now you can see that it had generated 1 is 5 times, 2 is 5 times, and 3 is 5 times. Okay, so that's replication. So either by number of times or by each. Or sometimes you want to just compute the you want to just compare a particular value with something like, let's say you want to find out all the elements of this array which are odd. So what you do is s0, okay, divided by 2, not divided by 2, percentage 2, what do you call, uh, so s6 all right equals to 1. You can see when you say condition like this, you have this is true, this is false, and rest of it false. Okay, or you could say things like greater than 1, so rest of it is true. You see that? So you could basically generate another vector by applying a condition on a vector. Okay, next is we could also pick up portions of an array. So let's say we only want to pick up values starting from 3 up to 7. So you could see from here 1 2 3, this is 3 4 5 6 7. So we have been able to pick and choose the values from S6. Okay, so these are the few operations on top of vectors. All right, now other than the vector we have something interesting called an array. An array is basically a matrix. Array in R is nothing but a matrix. So you can see that generate a 4 by 5 array. An array is a way to create matrix. And what is a matrix? Matrix is basically two-dimensional things. So an array internally is looking like this. You can see that. So let me try to explain to you. Given a vector like this, if we have to fold it and create an array, we can simply say array. So create array out of this S6 with the dimension of 2 by 5 or 3 by 5. Okay, you can see that it has converted our vector in our S6 into S6 into matrix. Okay, so what it has done is it has taken these values and put it into column wise. So we are able to convert our vector into a kind of a table. See that? So that's an array. Similarly, we could also pick up array like this. Now out of this array which we have just created like this, let me define it like A. A is this. We could always pick up a column or we could always pick up a row. You see that? So to pick up a row, you say the row number and then leave the second column name empty. If you want to just pick up a column, leave the row number empty and pick up that one. So you can see that, okay, you can see that we can pick up the particular column, and this gives us a vector again. Okay, to pick up a particular column becomes your vector. All right. So let's say we have X, okay, and we want to convert X into an array called Y, and we say array out of X, and dimension we are specifying as how much? So let me say, what is the length of X? 20. So, okay, this is correct then. Oh, okay, I got it. Dim equals to C 2 into 10. Now you can see that it has converted it into this. All right. Now let's say we want to wipe out the column number 7. Okay, so I can always say things like this and put 0 in that. Now the column number 7 has been wiped out. You can see all of them has been set to 0. Good. So these kind of things, these kind of magic things you could always do. All right. So these were arrays. Also, inside this index, we could again provide another vector saying 1, 2, 3. You can see. So we are picking, and what is y? Y is this. We are saying, give me the values for 1, 2, and 3. 1, 2, and 3. Okay. No, this is not right. Yes. Okay. So basically, you can. All right. So you can also provide another vector inside the index and pick up only those values. Okay. For example, let's just pick up column number 4, 5, and 6. Okay. So that's our column number 4, 5, and 6. You see that here? Are you guys with me, or have I lost you? Mehndi and Sahab, do you want to try it out? Do you want to try it out, Mehndi and Sahab? I can stay online. In case you get stuck, I can help you quickly. All right. Now, so Sahab and Mehndi, do you want to try it now? I can have the patience. So R basically provides you these quick operations, a way to manipulate data. And the data could be in the form of normal values like strings or numbers, or data could be in the form of vector or array. Array is like a big tabular format data. You can combine one array with another array. You can pick up, slice one row out of it. You can pick up one column out of it. You can do all kinds of magic on top of array. Okay, okay. So Sahib is saying that he will try later. All right. If you have any question at any point of time, please feel free to ask. Okay. You can try this cool way of representing data. All right. So I will show you. I hope this works. No, it did not. it did not. All right. So my plot is not working. Oh, it did work. Okay, okay, it was there, I think. Yes. So what did we do here? What did we do? We basically plotted the graph like this. Do you see the magic? What is happening? We created a vector starting from 100 till 100. Do you see that? We created this vector, okay? And then we multiplied each value of this with a square of this. So if you see, y is a big array of squares of x, okay? And then all we did was plotted it, okay? All we did was plotted it. So if we want to plot x and okay, so we have y and we have x and we want to plot x comma y, we can see this is our logarithm, okay? Or we want to invert y and x, so we could see that this is our logarithm, okay? Initially log of x is like this, and then as y grows, as x grows, y starts growing, but after a point of time y doesn't grow, okay? So you can quickly plot things and see how does your data look like. Any data uh, that looks like, I think you can do, okay? So let's say we have got c minus 100 till 100, or let's say 1000 by 1000, and I want to say x into x into x is my y, which is y cube, or y cube plus 10. And now I want to plot x and y. You can see the beautiful graph that has come out. And of course you can customize the colors, okay? You can see this doesn't look cool. Okay, so we have x this, and y equals to x into x into x plus, and then I say plot y comma x. You can see the beauty of this graph. It looks like S, right? So we are able to quickly plot the data, and when you plot the data you can do the analysis better. If you have a look at the data and then quickly able to visualize it, there are chances that you will be able to figure out what kind of data are we talking about, okay? Because same data, if you have here, so you have x and y, and you don't know what is the correlation between x and y unless you try to plot it. So let's say y is equals to, there is a very simple line, okay? A simple line as in comma y. Now you can see it's a straight line. Or there are some data, some points where some data is on left hand side and some is on other side. So you can always utilize the graph quickly and have a look at it, what's going on with the data. Okay, just that x and y both have to be vectors and to be given to the plot. Okay, are you with me? Looks exciting to you? So you can quickly, very quickly churn the data using R. Okay, so just based on this basic dynamics of R, the the vectors, the matrix, the basic operators, ability to use the functions, and ability to create a big vector at any point of time using these small functions and utilizing many other libraries. People have done a very marvelous job in R. Can you believe that there is there are there are libraries in R for even economics, machine learning, medical imaging, meta-analysis, and even things like clinical trials and genetics and high performance computing. So you can see that there are all kinds of libraries which are available as part of R package. Okay, so these interesting libraries are available for all kinds of. Is it visible to you here that there is something called there is one nice polygenics, and then we had a social sciences. Can you see that there is a library which can help you with doing the statistics of social sciences? Okay, that can help you do the statistics of social sciences, even the survival analysis. Can you believe this? There is a library for survival analysis. So R has got the richest set of libraries. Okay, so most of the cases you will be able to do things using R. Okay, only the cases where the data starts growing bigger than what can fit in the memory, only in those cases you will need to move out of R and go to things like Spark R. Okay, otherwise R is pretty much sufficient for you. Okay, so those who are little curious about churning more data, they should download some of the data from this website called quandl.com and get it rolling. Okay, get it rolling. You should download the data from here and get it rolling. Okay, so and load the data into R and start churning it. Okay, using libraries from R which can help you load CSV, you can quickly create here. So even here it provides you, there is a way to load data here. Edit, code, jump to, extract, reflow, reindent, source, view, plots. There was a way to load data. What is this? Here there is a way to load data into a variable. Just a second. Let me try to load some data directly. Yeah. Import dataset from a text file. Okay. So here, let's say I'm trying to load this nifty.csv, and I could say things like separator is comma, row names are okay, and that's it. And here, let's say I call it NSE, NSE, okay, and I say import. Now, can you believe that we have just loaded our data here? What was, yeah, it got imported into something called USE. All right. So you could import data from here, import dataset, or you can download data from a URL. Okay. So you can see here we are saying row name something. All right. And good. So we have been able to load data into X, and inside X we could say X give me only open. You can see that we got only the open values out of it. All right, sounds good to you? Let's say you want to plot high versus low. Okay, high versus low, and you want to check how does plot X. I pick up the column called high. I pick up the column called high, and then I'm going to pick up another column called low, and I'm plotting the two against each other. Okay, you can see that. So the relationship between high and low is quite linear. Okay, so let me again clear all. Yes, and then plot it again. Why it's you can see that it's mostly linear. As the value of a stock goes higher, it goes lower. Sorry, so high and low for the day basically. Okay, and that's what it is. And also, let's say you want to plot the data on the date and share trade it. Okay, so you can always say things like X, and you put date on the x-axis, and on the y-axis you put on the another axis you can put shares traded. So I think it's taking a little bit time. So it has plotted over all the dates of all the dates data. It is plotted for all the dates. You can see here, starting with 1990. All right. Does it sounds interesting to you? So this is just a way of analyzing data by just looking at it. This is just analysis of data just by looking at it. You could go deeper into data by doing further analysis, like you could first convert the date into only the year, and then compute the shares traded for that year, and then do all of this. Okay, So there are lots of libraries available for these kind of operations. Okay, sounds interesting. If you like to churn a little bit more data and try to look into what's in the data, you should be able to do it now. Also, have a little bit more details about R so that you're more confident in working with R. So, R provides you all kinds of operations to churn, slice, and slice and dice the data and present the data in the graph. R provides you the statistical operations very quickly. Along with that, R provides you these beautiful libraries for machine learning. Machine learning as in ability of a computer to learn from the data automatically. Okay, good. So this sounds interesting. We will start the statistical inferences now. You are all, you know, good in the good state to start in statistical inferences. All right. So we will talk about introduction to data, and there are two ways to reach to a conclusion, either by a thorough analysis or by going through the anecdotal stories. Anecdotal stories as in smoking. My uncle smokes 3 packs a day and he is perfectly in a good health. So, the idea of analytics is that you should not be reaching to conclusions based on anecdotal stories. And anecdotal stories are something which are not which do not give us the real meaning, because how many times you have heard that cancer has nothing to do with smoking. That's because those are based on the anecdotal stories. People with a very small data set, people are trying to reach to a conclusion. Or most of us are not even trying to analyze the data. We are just passing on the story from one person to another. And that kind of analysis or that kind of knowledge is very fatal and is not right way for any ana- analyst or any data scientist or any expert at data. So expert or anybody who believes anybody everybody needs to believe in data instead of the anecdotal evidences. Okay, all right. All right. So, with respect to data, whenever we are reaching to a conclusion, either the data is generated by the machines or we are gathering data by the way of human intervention, as in people go and gather the data. The overall objective of data analysis is to reach to a certain conclusion. Okay, so for example, the research question is, are consumers of certain alcoholic brands more likely to end up in emergency room with injuries? Okay, so these kind of questions, when we need to answer, you always have to select what kind of population is your research valid for. Whether your research is for all the people across the globe, or it's only for a small geography, or is it for a country. So basically, you first have to define the domain. So you cannot infinitely generalize your research. You did some research on a small subset of people in a geography. It's not always possible to extrapolate it for the whole world. Okay, because you might be experimenting on certain alcoholic brands here which are not available across the globe. Okay, therefore you need to define the target population. Then what kind of samples are you gathering for answering this research question? Okay, so you will specifically dictate, as in what is the sample data on which you are trying to do the analysis. Is it very specific to a certain geography, or is it very generic to all the geographies? So you need to figure that out. And you always, so you define something called a population, and you also define the sample, and you generalize to what level you can generalize the sample. Okay. So these are the uh, you know basic things with respect to the data analysis. And we will talk about all kinds of variables such as numerical, categorical, and there are many ways of representing a data. Okay. Either you could define something called numerical data, such as we defined 1, 2, 3, just now we did that. Those could be either continuous or discrete as in integers, and continuous as in decimal numbers. Then qualitative or categorical, as in when this webinar ends, you will see a form with good, bad, high, low kind of keywords, right? That is categorical. Now, inside the categorical, there is a range. Either it's a regular categorical, as in the names of the countries, okay, India and US, and so the names of countries is like categorical. There is no hierarchy in them. But good, bad, very good, very bad, there is a sequence, there is a ordinal. Okay, so those kind of variables, those kind of categorical variables are called ordinal, while there is a regular categorical. Okay. All right. So you can see this data. This is for all the countries. This is the Google Analytics data, or you can say this is the data given by Google to various countries' government. Okay. So these are the requests raised by various countries. You can see that Argentina, go- Google got 21 requests from Argentina. Google complied with 100%. Okay. And then there were other, requests for other kind of data. And for other kind of data, UD data, Google complied with 32%. And then the the region, I mean, whether it's southern or northern region, those kind of, that is hemisphere. And then HDI has been, I mean, the other variable, okay, which has got kind of a sequence: high, very high, low, very low. Okay, so you can see from here, this is discrete, as in numerical data. It's a continuous numerical, as in the values are continuous. It's not discrete. It's not just arbitrary. Okay, it is a percentage. And then you have categorical data, and that categorical data which has got a sequence, good, bad, ugly kind of data, which is basically a sequence of values. We can always say good is greater than bad, and bad is greater than very bad. Okay, so that kind of sequence, so that's called ordinal categorical. Okay, so these are the basics of data analytics. We will continue from here tomorrow at the same time. All right. Okay, so as a quick assignment to all of you, try downloading some data from quandal.com. I'll just copy paste it, and try to plot the data using R. Sounds good to you? Try to plot the data using R. Okay, that's your first assignment in which you can download this data, and that's the beginning of your career in big data analytics. All right, thank you very much and have a great day. Bye bye. All right, thank you, Mehdi. All right, bye bye. Have a great day. Do not forget to give a response on the webinar. All right, bye bye, Sahab. Have a great day. And Mehdi, please try to upload the video. I think my video will not be good today. Okay, so please upload it in your Dropbox and share it with me, or maybe in Google Drive or somewhere. All right, bye bye. Have a good day.